Alright, hello again. We're going to do chapter 12.3, which is an introduction to polynomials. The first thing we're going to go over is a little bit of vocab. We have a thing called a monomial, which is one term. It's one term that builds up where if we keep adding a bunch of monomials, we'll end up with a polynomial. So an example is something like 3. 3 is a monomial. It's a constant, and it's just one term. You could also have a variable if you wanted to, like x. It's a monomial, one term. Or you could even have them combined, like maybe negative 3x. That's one term. It's one piece of the puzzle for a polynomial. So we call it a monomial. So it gets its name 1 from mono. Same deal for binomial, which is 2 terms. And you can see the word bi, which means 2. So for example, you could have x plus 3. So there's 2 terms and they're separated by addition, so there we have a binomial. We could also have more complicated things like xy squared plus 4. Maybe we'll add an x in there. And that's a binomial. There's 2 terms. You can also have subtraction going on, in which you just remember the sign goes with the term. So you could have negative 3 minus x, in which one term's negative 3 plus the negative x. And those are our binomials. Trinomials has 3 terms. You can see that from the word tri, and poly means many, so many terms. Let's go ahead and do a little bit more vocab. We're going to talk about coefficients, which is the constant in front of a variable. The degree is an exponent or power of a variable. And to make these definitions go home more, we'll start off with a nice example where we're going to identify the terms, the coefficients, and the degrees of this polynomial. So terms are broken up by plus signs. So our first term is negative 3x cubed. The next term is 4x. It's positive because we have plus. And then the last term is negative 1. Now, coefficient is the constant in front of the variable. So whatever's in front of the variable, we have negative 3. That gives us the coefficient. Same deal for the next guy. We have 4x, so the coefficient in front of it is 4. Let's hold off on this guy. This one's a little bit funky, so let's go talk about degrees. So degrees are the exponent or the power of the variable. So looking at our first term, we have x raised to the 3rd power. So our degree is 3. The degree for the second term here, 4x, his power, while it's not written there, it is a 1. Make sure you remember anything to the first power is just the variable x. So our degree is 1. Now we're going to head into funky land, that negative 1. It's a constant. Now, the coefficient is the thing in front of the variable. You might be thinking, well, there's no variable. And I would tell you there really is a variable. I have x to the 0 here. And just remember your rule, x to the 0 is 1. And 1 times anything is the same thing. So 1 times negative 1 is still negative 1. Nothing's changed. I just filled in my x to the 0. So now I can see easily that the coefficient is negative 1 because he's what's in front of the x. And the degree, while not as pleasant, is there. It's what's the degree of the variable, which is 0. So we can kind of come up with our own rule. Constants, their coefficient is always whatever the constant is. So negative 1's coefficient is just negative 1. And their degree, since they have no x's, is 0. Let's try one more to hopefully shoot this home. So we have to identify the terms, the coefficients, and the degrees of each term. So terms are always broken up by the plus sign. So our first one we have is negative 6x to the 5th. The next term is 4x cubed. The next term is 5x. And the last but not least is 14. And let's go ahead and do the coefficients. So whatever's in front of the x. So negative 6. Front of the x is a 4. In front of the in front of the x is a 5. And then constants are always whatever the constant may be. So it's just 14. Fairly nice. Now degree is what's the degree of the exponent. And if there is no x's and it's a constant, it's always 0. So that guy's kind of nice. The degree for the first guy is 5, second one is 3, and last but not least is 1. Now you might be seeing something very nice appear here. Notice I listed out my terms as I saw them, and the degrees go down. They're in descending order. It went 5, 3, 1, 0. Even our previous example, we went 3, 1, 0. This is something we call descending order. And when we combine like terms, we like to see them in descending order. So let's tackle this new problem, where they're asking us to combine like terms, which like terms have same variable to the same power. So we'll just start with the first guy we see. We have negative 5x to the 4th. Now we're going to go searching for other people who have the same variable, so x, well everybody here has an x except the last guy, and the same power, so we need the 4th power. The next term is x squared. That's not the same, so no good. Oh, this guy's x to the 4th. We're only concerned about the variable and power part. We don't care what's in front. The coefficients could be anything. And then there's no other like terms. So when we combine these, we have negative 5 plus 7, which gets us 2x to the 4th. So we combine the coefficients when we combine like terms, because we're adding them. And now we'll continue on. We have an x squared. Is there any others? Nope, so we'll just leave it alone. Can't combine it with anything else. Continue on. We have a negative 2x and a 5x, which gives us positive 3x. And then last but not least is negative 1. This is in what we call descending order. I kind of just got lucky it fell into place, in which the highest degree is first, and then it continues down in that fashion. So it went 4, 2, 1, and then 0 for degrees, okay? And that's our answer. Let's see something about missing terms. Now, I'm telling you about descending order, in which we'll have x raised to some power, and then it would decrease by 1 and keep on decreasing until we're finally left with a constant. And these things in front here are just coefficients. The a, b, and c, and d, they're all just coefficients. X is our variable, and n is our degree. So n minus 1 is the next degree. Here, 1 is really the degree, and then there's no degree, it's 0. So what I'm going to show you is an example. Let's say I have x to the 5th minus 1. If I were to write this in a kind of funky way, where I could show you all the terms that are missing, I start with the highest degree, and then I work my way down going by 1. So from 5, I subtract 1, I'm at 4. Are there any x to the 4ths here? And you'd be like, no, why are you even asking that? Missing terms, I want to notify you. There is no x to the 4ths here. So I write 0x to the 4th, which is still 0, and 0 plus anything is still the same thing. And then I'll continue down. Alright, subtract another 1 from this. So 4 minus 1 is 3. Are there any 3s? X cubes, I mean. Well, there's none of them, so there's no x cubes. And there's also no x squareds. And there's also no x's. But we do have a constant, which is minus 1. So these things in between here is what we call missing terms. They're only important, wow, could not write that. They're only important when we are doing long division. For the most part, we don't use them too often. They're nice to keep in the back of your mind. Only tell me missing terms if I ask you to identify the missing terms. Alright? So let's see. My question asks you to identify the missing terms. And let's start off with a nice guy. Let's say we have x cubed plus x minus 15. Now I just want to identify the missing guy. So I first find the highest degree. Cubed. Alright, so I have x cubed. The next degree after cube should be squared. If there's none of them, that's a missing term, so I'm identifying it. There's no x squareds. The next degree should be x. Oh, we do have an x, so let's just write him. He still exists, he's still there. And then the next is a constant, which we do have. So here, when we look at this, this is displaying our missing term. And sometimes when your MyLabs Plus homework, it'll ask specifically state the missing term. So what they're looking for is the missing term is x squared. Let's try one more. Let's get a little bit crazier. Maybe we have x to the 6 minus 3x squared plus 24. And we're asked to identify the missing terms. So we have x to the 6. The next degree down is to the 5th, and there's no to the 5th, so we say there's no x to the 5ths. There's also no x to the 4ths. And there's no x cubes. Oh, but we do have x squared, so we'll have that minus 3x squared. There's no x's. And we do have a constant, and I don't know if you can see it. I'm kind of squishing it in, so let me move it over real quick. And we have a 24 at the end there. So we have a lot of missing terms here. So we have an x to the 5th missing, we have an x to the 4th missing, we have an x cubed missing, and an x. So when we write it in the expanded notation, it's very important we have the 0 in front saying there's none of them. But if there's ever like just state the missing term, you might list them off saying I'm missing the x to the 5th, I'm missing the x to the 4th, I'm missing the x cubed, and I'm missing the x. So this is if I were to list them off. Just be very careful. Listing them is not very different from plugging them in. If I were to write plus 1 x to the 5th, then I would actually have a term there, so it wouldn't be missing. So make sure you do have the 0 to say there's none of them. And that's all for this section.